Linux Kernel Module Cheat. So GitHub project, yeah. The goal for this project is to have the perfect emulation setup. So you run Linux on a virtual machine to understand and debug it. And it can be very useful for security people. How does it work? You can use a simulator to run very fast, and it's very cool. So first you run some random commands. These are the commands. And this gives you a Docker. I've just tested it on Ubuntu 24.04. And after you get this Docker, once you reach that point, everything will work for sure because you're in Docker, right? Hopefully. So after you reach that point, you run this command. This builds everything from source. So QEMU, Linux kernel, glibc, shell, blah, 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 everything. And then you do run. And after you do run, Linux boots, and you end up in a shell. No, so here I run pwd command, so a Linux shell provided by buildroot shell thingy, VisiBox. So far it's not too exciting, but what is exciting about this, in my opinion, is that everything is built from source. And I mean everything. There are no blobs. So QEMU is built from source. Linux kernel is built from source. glibc, GCC, everything is built from source. So it's extremely clean. And for the most important projects, I even have them as submodules of my project. So you can just, you have them git tracked, all the sources there. You can just modify things very easily. So for example, do you want to modify Linux kernel? No problem. You go to this function. If you want to modify the start kernel function, which runs at boot time. Let's put a print there. Then you do build Linux. Then you do run, and there it is. It will show up there. This build was really fast because it was a differential build. You can see that you can really modify things. Another really cool thing about having the source lying around is that we can use GDB step debugging very easily. So for example, if you wanted to GDB step debug Linux kernel, and let's say you want to debug the start kernel function now, instead of just putting a print, that we want to put GDB there, we can. So you just run GDB wait, run GDB start kernel with another shell, and after boot, which is really fast on keyboard, just a few seconds, bang, you get a GDB shell, and you can do common GDB things like go to the next line, list, BT, everything basically just works. Multiple architectures are supported. So if you want to change the architecture, super easy. Just say, oh, the architecture is ARMv7, and now run the architecture ARMv7, and it also just works. And I also have a lot of more content-oriented things in this repo because I use it whenever I want to test something that is related to emulation. I just dumped it there. So, okay, I have kernel modules, as the name indicates, about the project. Now, for example, hello.c is a kernel module, just like Linux kernel, just build, we run, and bam, there it is. I also learned a lot of assembly through this project. So I made minimal examples. For example, let's learn the add instruction of x86. 1 + 1 = 3, assertion. This is just a userland example, but because you need emulation to learn assembly, this is very convenient to put everything in this one place and just run it there. It's very clean. And another thing that I did in this project as well is even Baremetal, because of course this is unrelated to Linux kernel, but just kind of cool and also emulation focused. So I also have some Baremetal examples that you can run Baremetal features as well.